Welcome back to Spiderweb Education. We're going to continue our series on logic gates. Lesson 1 was about binary numbers, how to convert decimal to binary, binary to decimal, defining a byte and a bit. Lesson 2 is about buffer and not logic circuits. So let's get started. First thing I'm going to start with is the truth tables. I haven't really defined the truth tables yet. These two boxes down here are truth tables. What a truth table does for us gives us a nice visual, gives us data, and it tells us what our output is based on our input on our logic gates. So for instance, a buffer only has one input here, and so you can only put a 0 or a 1 or an off or an on or a ground or a something pulled high to battery, for example. Same thing with a NOT gate. So what we're going to do is walk through these circuits and figure out what our output is. So a buffer symbol looks like this. It has an input and it has an output. On our circuit, we have an input and we have an output. Now, we can see what our buffer does based on this circuit. So, for example, in our truth table, our input is a 0. So if it's a 0, we're going to put a ground on our input. If our input is grounded, our transistor is turned off. If our transistor is turned off, then our output is pulled through R2 to ground. So that gives us a 0 on our output, or an off, or just grounded. Now, if we take our input and now change it to a high or 1, or we pull it high, we turn on our transistor, which means now we get our transistor to conduct, and now our positive side of our battery is now our output. So now we have a 1 or an on or a plus VBAT. Now, if you look at the truth table, you can see input is a 0, our output is a 0, or if our input is a 1, our output is a 1. And you can ask the question, well, what good is this? Well, how about if this side of a circuit is maybe low voltage or low current, but that is feeding something that's higher voltage or higher current? This acts as a buffer, which is what it's called. Very useful to isolate maybe a high current circuit from a low current circuit. All right, let's look at the NOT. The NOT symbol is very similar, except it has a little circle on the end. It still has the input and it still has the output, and that's represented in our circuit. Here's the input and here's the output. Now, similar to the buffer, it only has one input, so you only have two options, a high or a low. So if we put a low in the input, or a ground, again, our transistor does not conduct and our output is pulled high to our battery voltage. So that will give us a 1. But if our input is pulled high, meaning it goes up to VBAT or it's turned on, then our transistor conducts, we get current flow, and therefore our output is grounded. So we get a 0. Now, if you look at this close, if we have a 0 on our input, we get an output of 1, and if we get a 1 on our input, we get a 0 on our output. So in other words, a NOT logic circuit can also be called an inverter. It will take the input and it will invert it. All right. So that is two logic circuits, a buffer and a NOT. We've gone over the truth table, so you know what a truth table is, and these truth tables will get larger as we get into AND gates, OR gates, and NAND gates. But again, they're very useful. All right, if you have any comments, please leave them below. And as always, please subscribe to SpriderWeb Education.